So, what's the degree? This point brings us the happiness. Is 100 or is 500? It must be something, either 100 or 500. It cannot be 100 and 500 at the same time, right? So these 2 points on the same level of indifference curve and these 2 points on the same level of indifference curve, but this kind of thing, the same points, are indifferent from 2 points on 2 different indifference curve. It can't happen. It just cannot happen. Okay? So you see the logic violation here, logical violation. That's the reason why we do not have cross indifference curves. So any 2 indifference curve cannot cross. Okay? And I may give you another logical inference. Something like A is indifference to E, B is indifference to E, but B is preferred to A because more is better, right? So, if you want to say this property is wrong, if you want to show others to prove the property here, so isoquants curve, not isoquant, indifference curve A, indifference curve B, you want to show or to prove this situation cannot happen. How can we do that? We just choose points 1, point 2, and point 3, and we make point 3 on the upper right corner of this one. Okay? So they are indifferent, so they should be indifferent by transitivity. And this cannot happen because of more is better, right? So this situation just cannot happen. And indifference curve slope downward. So this one cannot happen if more is better, But sometimes, I will tell you, sometimes we just have this kind of indifference curve, and I will tell you why. And I would like to introduce the last one first. So indifference curve cannot be thick. There's no thickness for the curve. It cannot be thick. Because if the curve is thick, then you may find 2 points within the belt, within the thick belt. And we may put some points just upper right to another point. And then the case would violate what? More is better, right? So again, due to the property of preference, more is better. So the indifference curve cannot be thick. It cannot be a belt, because within a belt we may always find 2 points. And one point is strictly preferred to another. They cannot just be indifferent. Okay? Alright, this one. Ice cream. This is something I like. Mushroom. Something I hate. Okay? So it's a good to me and it's a bad to me. So in here, in this case, for ice cream, the more the better. For mushroom, the less the better, right? It's a bad, the less the better. It's a good, the more the better. Okay, I have a bundle here, and I divide the plant into 4 regions. So which one do you think I would prefer points in that region? Which region do you think? For points in the region, I would strictly prefer to this point. Here, right? The reason is because in this region, points in this region, or bundles in this region, give me more ice cream and less mushroom, right? I would feel better. I would say, oh, I'm so happy. So this region just cannot be something indifferent to here, right? And also this region cannot, because less ice cream, more mushroom, I would say I hate this region, right? I would prefer this point to points in this region, okay? Only for points in these 2 regions can give me something indifferent to this point. Is that right? Is that right? Okay? Understand? So for this, because in points or bundles in this region gives me more ice cream but more mushroom as well, and less ice cream but less ice cream. Less ice cream, less mushroom. Okay? So it may be indifferent, but not all points are indifferent to this one. Only some points. And that's why when we have something, some good on one axis, and another good actually is a bad on another axis. In this case, we will have a positive sloping indifference curve. Okay? So the reason why we have negative sloping indifference curve is because the more the better, not only on this axis, but also on this axis. Good and good, so we have this. Good and bad, we have this. And I want you to guess. Now, we have 3 indifference curves. I call it 1 and 2 and 3. So which one may give us a higher level of satisfaction? 1, 2, or 3? Which one gives us a highest satisfaction? 3, right? Because points on the third, on indifference curve 3, points on this indifference curve gives us the most what? Ice cream and less mushroom. But here is more ice cream and less, more mushroom and less ice cream. Okay? So the direction of preference would in this direction, and this one would in this direction. So if, let me give you something, hamburger, Coke, and for this point, it's an interesting point. I'll call it bliss points. Okay? Bliss points means I like hamburger, but okay, enough. More than this point, more than this level, I would start to hate it. Okay? Think about, if you like ice cream, I give you a cup of ice cream, 2 cups, 3 cups. What about 100 cups in a day? 500 cups of ice cream in a day. Understand what I'm talking about? Get it? The more is better is something, is a property, but in real world, sometimes we just face the limitation or some real thing. I like this, but too much is too much for me. Okay? So I like ice cream, but if you give me 1 cup of ice cream, I would say thank you, and 2, appreciate. But 100, something too much. Okay? So there is a satisfaction, the highest level of satisfaction, which means if we come across this kind of situation, so hamburger is a good in this region, in this realm, in this range. And beyond this point, it turns to be a bad, because too many hamburgers, okay? And Coke is a good in this range. Beyond the point is a bad, too much, okay? So this point is the best one. And we'll have in different circles like this, in different circles. So for this region, for this area, is a good, satisfying the property of more is better, right? Good. So set it in this region said just satisfy the property, the more the better. So you just see the normal properties like we introduced here, like slope downward or downward sloping, and cannot cross and cannot be thick, and the farther from the origin is better. And in this region, it's just something like what I described to you, right? In this region, the good on the horizontal axis is good, but for here is a bad. So the indifference curve just look like this, and the direction of preference would be here. Okay. What about this? It's just the opposite one from this one. Bad for hamburger, but good for Coke. So it's a positive sloping, and the direction is here, right? And if for the 2 axes we have beds on these 2 axes, is again slope downward, negatively sloping, but the direction would be here, right? Okay. So that's the reason why we call this point bliss point. That's the reason why we call it bliss point. Some textbook would introduce this case, but not everyone. Not every textbook introduce this example bliss point or this idea, this concept. But I think it may be useful for you, so I just introduced to you. And normally, we will talk about the indifference curves, or our analysis will be confined in this region. Okay, most cases we will discuss within this region. Satisfying more is better property. Okay, but don't forget, sometimes we are facing this kind of situation, or sometimes here, or sometimes here. For example, I don't like study, I don't like exercise, so it will be in this region, right? Study, exercise, hours of study, hours of exercise, sports. So the best points for lazy people or couch potato is like this: 0 hour of study and 0 hour of sport is best for this kind of person. Okay? Any question here? Okay, we are going to the next slide, utility, but let's take a break first. It's 9:47, so I will meet you on 10. Okay?